Now here you can see this is what the S wave, this is what the wave, and here we have this of here you can see we have a relic wave, long wave. Just to imagine that what kind of impact will be. Just focus on this side. Because of long wave, we will have this kind of shifting of rock blocks. Because of the relic wave, we'll have a adjustment in the spring of surface side to side. Shadow zone we have already covered. I hope you remember P wave and S. So P wave is able to pass through all the layers. However, it is reflecting the properties. S wave is also same as that of the light wave kind of properties. Infrared, they will band when the. I hope now you can. Layers are there because of these path, and if these are actually changing their path, it appears curvy path in straight one. Because of the change in density, again, if change in density appears like a curvy shape. Here we have a curvy shape because of the change in terms of. So when the earthquake generated seismic waves, they travel in all directions throughout the Earth's surface. But I hope you remember, because of this differentiation, these waves behave differently. We have 105, 140, we have zone, we have 105 and 140, we have. And yes, from 105 to 105, we have what? S waves, where the S waves. Here, I hope you have already discussed this. Not going. You want to see, go and watch in of Earth, like distribution of earthquake. Let's see the distribution of earthquake, that how there is a distribution of earthquake. So the distribution of earthquake is closely having a proximity, having a close proximity according to the plate margin. Wherever you see the plate margin, you only apart from the plate margin, wherever you see faults in the plates itself, or let's say earthquake, they are also likely to observe away from the edge of plates. They are likely to be observed interplate. They are likely to be observed on the mid plate as well. Based on what? Based on faults. So if faults are there at the mid plate, you will see the earthquake. So we have a two set of criterias where the earthquake proximity can be traced with that of plate tectonics. The very first is what? The very first is the edge, the margin of plates. Wherever you see the margin of plates, there you will see what? Earthquake. Simple. Then from the away from that particular plate margin, away from that particular edge of plate, or let's say mid plate, interplate, you will see earthquake, and that is because of faults has been created because of the tectonic movements, because of the movement in the plate itself under the influence of Mantle convectional current. So most of the earthquake, if you see, they occur along plate boundaries. Yes, some within. Now their distribution can be grouped in seismic belts. So here we have a very first seismic belt, that is the Circum-Pacific Belt. I hope you remember, and I hope you remember the plates basically. Yesterday or in last session, last to last session, discussed that here we have these plate margin. I hope you remember we discussed about how Andes might have formed, how Rockies might have been formed. Andes are here, Rockies are here, how they are actually being formed. We'll have a deep dive on these particular mapping aspect some upcoming sessions. So this entire plate is being known as what? Pacific plate. Okay, oceanic plate, Pacific. and here the Pacific plate is interacting with South American plate, continental, North American plate, continental, Eurasian plate, continental, and here some part of Philippine plate which is oceanic in its nature. Okay. So majoritarily you can see we have a continental and oceanic plate, subduction is there, so volcanism is there, but similarly at the same time we have what, the pattern of earthquake, and here if you see this is called as what, Pacific ring of fire, because here we have an active volcanism because of the subduction of oceanic plate beneath the continental one, and as there is a subduction there will be a shaking, there will be a movement in the ground, in the crust. As a result of that, earthquake will go place. So the very first is Circum-Pacific Belt. The very second belt where you can see the earthquake prominently, that is the Alpine Himalayan belt. Now this Alpine Himalayan belt is basically, here you can see we have an Indian plate, here you will see we have an Arabian plate, here you will see that we have what, the kind of African plate interacting with Eurasian plate. So along the plate margins you will see earthquake always, and yes, these mantle convectional currents are still actually operating. As a result of this, these plates are still moving, these plates are still mobile. As a result of their mobile nature, they will lead to the earthquake. Equally or parallel to that, they will also lead to the formation of volcanoes. So the very first belt is Circum-Pacific Belt or Pacific Ring of Fire. I hope you remember Pacific Ring of Fire. You can hear, and it's, so this is what Ring of Fire. So it encircles the Pacific Ocean, Pacific Ring of Fire. Actually, circling the entire Pacific, and it is most active earthquake zone in the world. If you see the earthquake which are taking place in the world, almost 68 to 70% of earthquake place here, this Ring of Fire region. It's a wide plate. Okay, a wide plate, basically Eurasian. I mean this Pacific plate. Sometime at some point of time it may interacting with the South American, North American. Large land masses are. That's why it is highly active in terms of earth. 70% of earthquake. So the regions which are impacted because of this kind of the plate kind of activity, and here you will see the Philippines, here you will see Asia, you will see Asia. Then we have a New Zealand, then we have a west coast of North and South West. These are the reason which is going to affect mostly because of this kind of earthquake, or let's say distribution. Moreover, we have California, Chile, and Alaska. Here you will see we have a California. Here you will see we have Alaska, and yes, here you will see what, Chile in South America. So these are the zones. Here we have a subduction, and yes, along with the volcanism, we have a violent earthquake activity. Second belt we discussed. Second belt is basically mid-world, or let's say Alpine Himalayan belt. This one, Alpine Himalayan belt or mid-world belt. Now this region is extending from the Mediterranean Sea. Sea there. Now Mediterranean Sea is basically the water body which is sandwiched between Africa and Europe. Okay, so there is a one water body which actually located between the Africa and Europe. It is very wide water body, and I hope you have this idea. Okay, where the continents are there, where the oceans. However, these much scaled matter. Here we are covering, as of now, we are all right. Alpine Himalayan belt is there. So with respect to the Alpine Himalayan belt, however, I'm trying to give you more and more aspect. Actually, don't bother that mapping kind of ideas. learning, you have mapping, we are doing it, but we are doing with respect to topic specific. Okay, later we'll have a more intense map. All right. So this particular belt is from Mediterranean Sea going through all the way in region, all the way in Himalayan region. Okay, and it is up to the Myanmar and Indonesia, up to Myanmar and Indonesia part. So Mediterranean Sea, Arabian region, India and Indonesia, Myanmar to Indonesia. So this is the region where you will see earthquake. It accounts for almost 20 to 21% of earthquake of the world. Minor earthquakes are there with respect to the world level, but yes, it is formed due to the collision of Eurasian, African and Indian plate with respect to their counterparts. And yes, the most quakes or destructive quakes which we have seen is in Turkey, Iran, in Nepal. We have seen some of the destructive earthquake, especially in North India. So because of the tectonic activity, continental convergence, earthquake. However, these earthquakes are not that much violent as compared to the earthquake which are taking